Section 4.3 deals with differentiating the log function. Here's the basic log function and the more general log function. So we've got two rules for doing this. First of all, if we're going to differentiate just the regular log function, the log of x, this turns out to be 1 over x. And if we differentiate the more general log function, this is going to be use of the chain rule, where if we're going to take the log, differentiate the log of some function of x, then what we do is, I'll think of it this way. I'm going to look back over here. What is this? This is 1 over the argument. Now the argument is what you're taking the logarithm of. So it's 1 over the argument. Now the argument over here is g of x. So there's the argument here. So this is going to be 1 over the argument, 1 over g of x, times the derivative of the argument. This is really an application of the chain rule. What you can do is think of, you've got an inside and then you've got an outside here, right? Here's the inside, here's the outside. So it's going to be 1 over the inside, 1 over the inside times the derivative of the outside. So just for example, suppose we have something like this. Let's take the derivative of the natural log of, say, 5x squared plus 3x minus 2. So this is going to be, here's the argument right here. So it's 1 over the argument, right? 1 over the 5x squared plus 3x minus 2 times the derivative of the argument. So the derivative of the argument is 10x plus 3, and then I'll just put it all together and write it as 10x plus 3 over, let's see, 5x squared plus 3x minus 2. Here's another example. We want to differentiate this function right here. So I see a product. You see it too? Here's the first factor, here's the second factor. So I'm going to use the product rule, which we know goes derivative of the first times the second, plus the first times the derivative of the second. So let's see where this takes us. Derivative of the first is 12x cubed times the second, natural log of x to the fifth, plus the first, 3x to the fourth, times the derivative of the second. Now the second is a log function. So I know how this goes. It's 1 over the argument, so it's going to be 1 over x to the fifth times the derivative of the argument, times, okay, now here's the argument. The derivative of the argument is 5x to the fourth. Now we can, of course, fix this part up over here. So let's simplify it. 12x cubed ln x to the fifth plus, now what happens over here? I'm going to get the 3 times the 5, so that's going to be 15. And then I'm going to get x to the fourth times x to the fourth is x to the eighth. So I can write this as 16x to the eighth over x to the fifth. Then I can deal with these two here. So how about 12x cubed ln x to the fifth, that's a 5, plus 15, and then what happens here? 8x is up here, 5x is down here. I can cancel 5 of those 8, so this is going to be just x cubed. Well, now it looks like I've got an x cubed here and an x cubed here, a 12 and a 15. We can take a 3 out, an x cubed out, so what's left? A 4 natural log of x to the fifth plus 3 into 15 is 5. There we go. I think that's it.